So, splitting cane is a very important part of my process for making reeds. I find that in order to get comfortably playing reeds, I need to have cane that is split symmetrically. Now, of course, cane is not manufactured, it's a plant, and so it has some natural variability to it. So we can't expect cane to be perfectly diametered and shaped. So instead, we should work with what we have, with the diameters, rather than for some theoretical piece of cane that does not exist. And so the first important thing when you look at a piece of cane is you should notice that the cane is not actually round. It's round, but it's not circular. And this is a pretty good example. You can see it's quite oval. I hope that comes up on camera, but it's not round. It's ovoid. This is just how the cane grows by nature. If I had to guess, it has something to do with the leaf coming off of one side of the stem. But we have two diameters, and though they're very similar diameters, they're not the same, which means that the rate of curvature of the cane is always changing except at 4 points: the minimum or the maximum diameter and the minimum diameter. Here I've drawn out basically, you traced diameter or radiuses of 12 and 12 and a half. They won't have the same arcs if you superimpose them. And so here is another example where I've drawn a bit more oval, that we have a very high arch and a very low arch of this curvature. And our goal is to identify them and to separate along these. The best we can, of course. I will thus far refer to these as, and going forward, refer to these as the minima and maxima. This is to be, the biggest diameter and the smallest diameter. And for me, this means having these the goal is to have these portions of the cane at the center of the reed. So we need to identify where they are, and then cut in between those lines. As you can see here in the blue, with this being the maximum diameter and this being the minimum diameter, we want to try to find the in-between point and split along those. We don't want to split on these lines, because then we will actually worsen the problem of changing diameter by always having a changing diameter from left to right. We can't be perfect, of course, but we can correct the splitting a little bit later when we use the pre-gouger or the gouging machine, because we're going to mark on the tubes of cane where the center is, or the diameters are. And so you may ask, why specifically do you want to split along these diameters, or at least in my opinion? And the answer is that because there's only 4 points where the diameter is of the, let me rephrase. There's 4 points in this tube where from left to right, if you were to view it as the center line, that the rate of change is the same, if not similar. Everywhere else on the tube, if you were to split along these lines here, you have a changing curvature from very flat to very arched. And so if we split with this at the center, that means that the rate of change of the curvature is about the same from left to right. The cane itself, we imagine as two circles, but in reality, the curvature is eccentric, meaning it's changing from one specific diameter to another. And again, the minima and maxima are the only points where these are relatively the same on the left and the right of it. So the goal with proper splitting is to get a tip opening, excuse my drawing skills, is to get a tip opening where it's the same sort of arc on left and right of the blade, either without collapsed sides like this or with collapsed sides like this, excuse my drawing. If you don't split this way, of course, this is an exaggerated drawing, but you'll have a very flat side and a very arched side, or even a side or edge of the reed that doesn't close at all. And if you look here with this very arched side and this very flat side, I can tell you immediately what part of the cane this is. This is where the maximum diameter is on this side and the minimum diameter is on this side. And between these changing points, you can actually see an imprint of these diameters in the final reed, because cane has a sort of memory. If we gouge the same thickness from left to right and scrape to the same thickness on left and right, the curvature will remain. Now, of course, we can't be perfect. The cane itself is not a perfect material. But the more precise we can be, the less extreme these effects of the unnatural nature of the cane will be. Cane is variable, but we can try our best to reduce the variability inherent to the cane to predictable inaccuracy in our machining and our working of the reeds. So, take an actual piece in real life. Here is a piece of cane. This is some cane that I just got in. And before we can measure the diameters, I like to take a quick look and look for any anomalies in the curvature or the bend of this cane. And we can see immediately there's a pretty sharp bend where this is quite straight, but this drops off at the very end. And so we don't want to start using this as a point of measurement for the diameter because it's changing in another axis that we can't accurately predict. And if you see here at the end, there's also a little bit of inaccuracy at the very end. This is often very common with the tube of cane. So I take a piece of cane just to give myself an idea of where a straight portion of the reed will be. And we want to use the center of the reed as a baseline because the tip is the widest portion of the reed. It will reflect the diameter the most. So I'm going to say that about right here is a reliable place to measure the diameters. Now I take my calipers. This is just a cheap pair of digital calipers. You don't have to use something nice, just as long as you can read the difference between the measurements. And immediately I will go for the smaller diameter, and you'll see why in a second, that I'll push with this hand on the wheel with a pretty loose caliper or a loose lock and rotate it left and right until it sticks. And this we know is the smallest diameter because it can't possibly rotate anymore. So I will lock the caliper, and with one eye open, I will mark a line parallel to the jaws of the caliper the best I can. Like so. You see that these are about parallel to the jaws of the caliper. Hopefully that comes up. And this is going to be an indicator of the maximum diameter because we're drawing these lines perpendicular. But it will all work out in the end. And so now the slightly more difficult, keeping the same measuring point, we're going to rotate the cane and watch the numbers on the caliper go up. And once we find the widest point, generally it's about perpendicular to the line we've already drawn, but not always, because cane, the more oval it becomes, the less likely it is to be at right angles. Very round cane, you can sort of ignore, you can get away, not ignore, but you can get away more with the issue of diameters, but very oval cane, this becomes very pronounced. So there you have it. I've drawn in the approximation of the minimum and maximum diameters at this point, which if you're starting out, it's good to actually mark this point, which, how about this? I will mark along this length because that'll tell us when we're splitting and cutting parts off the ends where our measured center is. So I will admit, I do use a cane splitter because I process a lot of cane. Ideally, the correct way to do this would be with a knife directly in between these lines because you'll get a slightly wider portion from the flat piece and a slightly narrower portion from the more arched piece, and then you don't have to worry about centering it as much. Admittedly, I just use a splitter because I'm trying to average these four lines and we can fix it in the pre-gouging stage. So with the bright light behind me, I will center this, and unfortunately I can't show you this very well, but the idea is to look through the splitter and center each of the lines we've drawn. Maybe you can see that. And center each of the lines we've drawn so that they are at the, as best we can, the center of the piece. So now that I've got them centered, and if you can see, on this very arched piece, the line is almost at the center. On another piece, it's just about at the center. And that's that same diameter that we just measured here, that we were measuring the arc of by measuring the diameter of the tube. So that's my method for splitting with reasonable accuracy in a convenient amount of time. You could spend way more time doing this, but frankly, this is good enough for me. I hope that helps.